their keen interest towards IEA activities. In this regard, I thank Periyar University organizer who has arranged this incoming meeting. I would like to introduce our today's guest speaker, Dr. M. Muthuraman. Dr. M. Muthuraman joined NTPC in the year 1999, received ME Design and Production of Thermal Power Equipment from NIT Trichy, and Ph.D. from Environmental Science and Technology from Tokyo University, Japan. Tokyo Institute of Technology, Tokyo, Japan. He is presently holding the post of Additional General Manager in NTPC Limited. He has worked at Netra R&D wing of NTPC, O&M department in Tjlc Super Thermal Power Station, Environment Management in Sipat Super Thermal Power Station, and Project Engineering Department of NTPC Limited. He is Fulbright Nehru C2 Fellow in the field of Management and Leadership Development R&D. His research interests include combustion, heat transfer, renewable energy, waste to energy, carbon capture, boiler design, improvement in operational practices, and optimum use of resources. Now I request our speaker, Dr. M. Muthuraman sir, to deliver a speech in the topic Waste to Energy, Opportunities and Challenges in India. I welcome, sir.
Thank you, madam. Thanks for the introduction, Jay Sumati madam, and all, especially my friend Srinivasan for introducing to Tanjavur chapter for this kind of presentation. I would be glad to be deliver presentation on this one. Can I start, madam? Can I share the presentation?
You can start. They will join.
Is it visible now?
Yes, sir.
Okay. Good evening, everyone, and I hope I can able to continue the presentation in English because I'm far away from my native. So maybe sometimes please bear with me. Sometimes I mix with Tamil and sometimes even in Hindi also. Okay, so let us.
Japan also you can speak, sir.
you see, basically, I have.
You finished your PhD there in Japan.
Actually, now if I openly saying, my fluency in Japan is better than Hindi and English.
Okay, sir. Sure.
Basically, that is the beauty of that Japanese government. So whenever any scholar comes from other country, they used to give 3 months, the continuous training, basically the course, Japanese course. So within 3 months, they know that's especially for Indians. So we are better at learning other extra languages.
Sure, sir. Sure.
So I seen many people from different parts of the world used to come to Japan for higher studies. But the professor from Japanese language studies, there is a separate department in my university. He used to say that Indians are very smart and a kind of so they used to learn other language very fast.
Very fast. Sure.
Yes. So that's the way because we are highly flexible compared to other country candidates. Okay, let us start about today's topic on basically that power generation from municipal solid waste, and this is very new concept in India. And basically, if you are a young entrepreneur, there is a lot of scope for young entrepreneurs to enter into this sector because this is an emerging sector in India. Although this is matured in the so-called developed countries in US, UK, Japan, kind of North, South Korea and all the countries. But in India, it is just emerging. And in India, NTPC has done a lot of initiatives in promoting waste to energy. And let us see about what is meaning by waste to energy. Means Now, basically, this presentation, I hardly cover about these kind of contents, like what is the opportunities for waste to energy in India, what is the potential and what is the generation potential availability in India, and what is why we are going for waste to energy, why not other technologies, and various initiatives taken in NTPC. And basically, I also cover a little bit about that our the maiden initiative in Varanasi. We have installed a waste uh, to energy plant based on uh, gasification technology. This is one of the proven technology in this sector. Basically, when it comes to waste to energy, there are a lot of waste is available. You can say there are different kind of waste, and like municipal solid waste, animal farms waste, e-waste. People are familiar about e-waste and hospital waste. And another one more area is construction and demolition waste. Means it is kind of construction material waste like concrete whenever you demolish any building or structure, so you ultimately end up in construction and demolition waste. So these are the different kind of waste we used to deal with day to day life. But today we concentrate our focus mainly on municipal solid waste. We used to call it as MSW. Then the question arises, what is meant by MSW and why the name comes, this simply called as a municipal solid waste. M for municipal, S for solid, and W for waste. And people may ask you why it is called MSW, or why it is municipal. Because basically it is nothing but a waste which we are generating day to day life, like your kitchen waste, paper. Hardly it contains like papers, mainly paper, food waste, vegetable peelings, rags, food materials, packaged materials, those kind of waste. Means it originated from our household. It is called municipal because the responsibility of disposing this kind of waste lies with municipal corporation. So that's why the name comes like municipal solid waste. It is also called as urban solid waste because in some places people used to call urban solid machinery instead of municipal corporation. So it is both the same municipal, but MSW is more prominent. So you can able to hear this term frequently whenever if you enter any municipal corporation. So that's why the name comes about municipal solid waste, that is MSW. And is basically the waste from hotels, restaurants, or household, mainly household. Those other things are many miniature in nature. But nowadays, one man trash is become another man treasure. Because I used to give this presentation for the last couple of 1 decade, you can say last 10 years. So I always used to quote this example. One we cannot avoid in life is there are three things you cannot avoid. The one is birth, another one is death, and the final one is waste. So whatever we do, whatever action we do, whatever may be the business or whatever may be the activity we do, we ultimately end up in some kind of waste. It may be a liquid waste, solid waste, or gaseous waste, or radioactive waste. But ultimately, each and every activity, whatever we do in any society, we ultimately end up in waste. But we generally call it as a waste until we find some useful application for it. Previously, we are very familiar about childbirth, the tube connected between that the mother and the baby, that cord. That cord definitely, previously what we used to do, we used to cut the cord and we used to throw it out as a medical hazardous waste. But now there is a lot of value attached to it. Now people used to preserve the waste, and in high low temperatures freezers, it is become a medicinal property. So people used to treat any kind of illness. So that's a very beautiful example. So far we used to throw that kind of tubes between baby and the mother, the cord, but now it has value attached to it. So whenever any value attached to it, we never call it as a waste, it has become a resource. So similarly, we used to throw out our garbage. We simply used to call it as a garbage. So garbage, so far there is no value attached to it. So we used to throw it out as a waste. We simply term it as a waste. But if somebody comes here and take the waste and generate some power, some useful application, then it becomes the resource. So that's why in the world there is nothing called waste until you find some useful application. You see the pictures, I think it is visible. This is the situation everywhere in India, wherever you go. In Chennai, some of the pictures taken from Chennai and some from Delhi and Bombay area. But the similarity is that in all the metro cities, even in B class cities, we are not able to maintain our waste, and we cannot able to do it scientifically and dispose it environment friendly. You see, it is not only occupying the large chunk of space in the cities, but it also create lot of environmental pollution. It not only create, because some of the pollution is not visible. For example, dioxin and furan. These are the carcinogenic gases. It is colorless, odorless, and it is not burnable. So these kind of gases are produced in this kind of dump yards. In Chennai near Perungudi, if you go to Perungudi area, there is a very big heaps are made out of this waste, and it started burning. Obviously, any organic material, you keep it for a long time. First, what will happen, that whatever the material, that moisture in the waste is squeezed out, and you see in the right topmost corner, you see the blue color, that kind of black color liquid used to come out. It is called leachate. The first leachate comes out, and that leachate mixed with the groundwater, then it highly pollute that groundwater. The next one, whenever the water comes out, it become dry. The dried waste become slowly get ignited and creates lot of smoke. Then that time the dioxin and furan start emanating from these kind of surfaces, and this dioxin and furan, as I mentioned earlier, is a highly carcinogenic gases. Once it enter into our body, it stays long. So it mixes with our protein, and it takes long time to degrade. So that's why it directly affect that human reproduction system. That's why in major cities, nowadays the population is coming down sharply, and you hardly find people in cities, maximum 1 or 2 kids. So these are the some of the main reasons for that one. So it directly affects our human reproductive system. So that's a very highly dangerous, and people not aware. But nowadays people have started giving importance to waste disposal as well. So that's why I told you, there is no material in the world we can term it as a waste until we find some useful application. And we must also be very careful about regarding the technology selection. That kind of people used to promote. The foreign countries, they used to generally, all the technology developments being taken care by foreign countries. So we must be very careful in selecting technology or importing technologies, because the classical example is, we used to use the real lemon for hand wash, but the artificial lemon for making juice. But it should be the other way around. But that's why we are in the dark. We are not able to put our effort to distinguish between which one is correct or not. So we must be very careful about the technology selection as well. And then, is it visible now, slide, sir?
Yes, sir.
Yes, sir. Please continue.
Yes. Now let us see about that waste to energy. Whenever you go into any kind of topics, kind of doing some kind of scientific research, so better to find out the history of the problem. And I am working in a coal-based power plant, that is NTPC. We almost nowadays we are generating more than 65,000 megawatt in the country, and we are the single largest company in India. we generate power from mainly from coal, mostly almost 70% you can say from coal, and remaining 30% from oil, gas, and recently we entered into solar, wind, other kind of renewable energy sources. And as you know that, you can able to appreciate if you are a mechanical engineer, if you can able to appreciate a kind of fuel, there are different kind of fuel we used to have in our power plant. That is coal, gas, and oil. Even in the coal, even under the coal, there are different kinds. That is anthracite, bituminous, and another one is lignite, because NLC is there. So people are aware about NLC. So that is also a coal, but different kind of coal. So first of all, whenever we want to use any kind of raw material as a fuel, we must be thorough enough about its properties. You see, suppose we want to use this MSW as a fuel, we must know about these properties. When it comes to coal, you know that coal is very uniform material, like petrol, diesel, kind of liquid fuels. But when it comes to MSW, municipal solid waste, so whenever thereafter, if I say MSW, it is a municipal solid waste. It is highly heterogeneous in nature. It is a complete mixture of burnable and non-burnable waste. You see, just imagine what is we are throwing out from our kitchen. We used to throw out vegetable peelings, left out food materials, food packaging materials, battery, glass, whatnot. Everything which is not, there is no economic value attached to it, we just throw it out. So everything come into MSW. So it is highly heterogeneous. One cannot predict. One cannot predict what is going to come today as a waste. And another peculiar is this: India is highly, diversified country. If you go to South India, because we eat idli and dosa every day, our kind of waste is different. And if you go to North India, their lifestyle is different. So chapati will be their majority, food. So there are different kind of cultures in India. So if you go to Mumbai, if you go to Calcutta, then you see it's puri, made of rice. So that is dominating. So this kind of waste is going to change from place to place. It is not constant throughout India. Okay, so it varies from place to place. And next one, it is again going to change with the season. There are some season, marriage season. There are some marriage season, you find lot of, banana leaf in the waste. So there are some other season, summer season, winter season. So this property of MSW is going to get affected by the season, your lifestyle. And you see that, the rich, if you go to rich community, the waste which is coming from the rich community is different than the people who living in some different areas, slums and all areas. And the second important thing is the moisture. Especially in Indian content, we used to throw out mostly the food waste. So almost 60% of the MSW is the moisture content. So whenever you want to use as a fuel, just imagine 60% moisture is there. First you have to operate at 60%. And the third important one is low density. This weight is having low density. So if you want to transport the fuel, you need a number of trucks, because each truck can handle only 4 or 5. If you see with Tanjavur Municipal Corporation, they can hardly handle 4 or 5 tons per truck. So there will be a lot of, trucks has to be played. So there is a lot of transportation expenditure involved. And finally, that lower calorific value. So obviously, any fuel having high moisture content and low density and highly heterogeneous obviously result into low calorific value, means low energy content. So if you use the waste, then energy content will be lower. Okay, up to this one is okay. We can able to manage by we can find some technology to use the low calorific value. But what about the next one? The bad odor and stinky smell. Because this is the organic kind of waste, you cannot keep the waste for long days, long times or long hours. It started decomposing because it is having short shelf life. If you throw it out and keep it for some hours, it started decompose and it create lot of stinky smell. So that is a major issue. And obviously, it contains lot of harmful bacteria because people are not aware. They also used to throw your medical waste along with the MSW, but it should not be the case. But ultimately, we will end up with very low energy content waste. We have to handle it. And what is the advantage? So there is a problem side we have seen. The waste is having a challenge. So that's why whenever there is a challenge, there is opportunity. So that's why the last slide we have seen, there's a lot of challenges to use MSW as a fuel. That's why there is a lot of opportunity for young entrepreneurs. And let us see about what is the advantage if you can able to do or scientifically you can able to displace the waste. First of all, we can save the land because this Perungudi or Noida area near Delhi, there is a lot of heap or mountains are formed. It occupies more than 50-100 acres. If you can able to dispose the all kind of waste, you can use those lands for real estate, building some kind of common facilities. So first of all, we can save the land. It is prime land, it is not in the outskirts. And you can able to appreciate why these waste mountains are built in the city itself, because as I mentioned you, we cannot transport the waste for a long distance because it is having very lightweight. There is a number of trucks are required to transport. So that's why generally all the waste mountains it being built in the city are roughly around 15-20 kilometers within the city premises. So if you can able to dispose it properly, you can save lot of land, and obviously you can save hydrocarbon import. Because we can generate power. By using generate power, you can reduce the load on the thermal power plant, and obviously it will reduce emission, whatever emission I told you, dioxin and furan kind of emission, and it can generate employment opportunity as well. So there are a lot of advantages there if you can able to do it scientifically. And that we have seen the MSW having different kind of constituents, both organic and inorganic waste. It is having different kind of decomposition time. So we must be very careful about that decomposition rate, so that we should not keep the material for a long time as a shelf life. Now comes the very important point: whether is it so critical to worry about waste disposal in India? Is it really worth to spend time or energy, focus on waste to energy or waste disposal? You see that there are tables are given here. It was roughly 5 to 10 years old table, but it holds good. In Chennai, we are generating roughly around 5,000 tons per day of waste. Roughly 5,000 tons. It's not 5,000 kgs. It is 5,000 tons per day. And if we go move towards Delhi and Greater Mumbai, it is roughly anywhere around 8,000 tons per day. So just imagine this much amount of waste, quantity of waste to be disposed. And just imagine one truck can handle 4 to 5 ton, and just imagine 5,000 tons. So how many trucks are required? So these many trucks are playing in the city, maybe in the early morning, not in the peak hour. But just imagine how much diesel or petrol we are using, spending it for the transportation of waste. It is very huge, And in India, in total, 55 million tons of MSW is being generated. 55 million ton, and it is started increasing by 5% every year. So it's every year there is an increase in waste disposal, because we are, what you can say, we are improving our standard of life or improving slowly. So it is also one of the another point is that the highly developed countries generate more waste compared to developing countries like India, because in India people used to call it as a per capita waste generation. In India, we generate 600 gram per person per day waste. But in developed countries like UK, US, Japan or South Korea, they generate around 3 to 4 kg per person. Roughly around 5 times they are generating more than what we are doing. So we are generating 600 gram only, but they are generating 3 kg per person per day. So it is also one of the another indicator of your development. But it should not be the case. It should be the other way around. Whenever you develop, you should also reduce your waste generation. But people used to indicate in different kind of methodology. And when it comes to composition, you see just composition, roughly around 50% is your food waste, and all other waste are you know not that much level. Pepper waste. Pepper waste is not exactly pepper waste; it's a pepper small spreadings. So roughly 50% waste is food waste. Whenever waste is food waste, the water content is very high. That is 60%. And again the same different kind of presentation only. It clearly indicates that biodegradable waste, that is called food waste. So food waste is coming under biodegradable category. It is having 50% constituents in MSW, and it having 60% moisture, more than that. And other things are like recyclable innards are a little bit less. Okay, then because always it is our habit to compare with others, because as a human being, we always we will get better sleep whenever we compare with others. So comparing with others is always another criteria for our self satisfaction. You just imagine a comparison between Indian waste and another waste. LIC, MIC, HIC is for low income group countries, low income countries, medium income countries, and high income countries. So you can say high income group like US, UK. Those are developed countries, so-called developed countries, US, UK, Japan, and you compare with the waste from Delhi. The first thing you see, just first row, food waste. Their food waste is very low. You can say average food waste is only 15 to 20%, but you see about Indian waste is around 60%. So we are wasting more food waste than other countries. So whenever the food waste is more, your moisture content is more. The next row is the pepper content in the waste. Their waste is having 50 to 60% is pepper content, but in India you see only 5%. You see why? Because we used to recycle the pepper. So because Kapadiwala is there, Kapadiwala means newspaper, the old newspaper guy. He used to come and get the paper done. So that's why we used to recycle everything. But in other countries, developed countries, you need to throw out that newspapers at a free of cost. So that's why it goes to ended up in the waste only. And ultimately you come to the last one, that is dirt, ash, etc. In developed countries, it is roughly around 10% only. Ash means sand and inert materials. It is not going to help your energy content. But in India, you see 30% is from dirt and ash. So if you want to use a material which is having 30% ash, so just imagine if you are having 1 kg fuel and the 300 gram is useless, it is equal to that one. So 30% ash we have to deal with the waste. So if you burn a waste, you end up with 30% ash in it. So that's why you just imagine this slide is very, very critical, because our living condition, our climate, our religious activity, is highly complex, and we are diversified country, and that's why we cannot predict our waste. If we compare with other countries, our waste is entirely different. It clearly shows our waste is entirely different than those of other countries. Then now you tell me, can we import a technology? Can we import a technology which is designed for their own kind of waste? Maybe America, Australia, US, UK, Japan. Each and every company, every country has developed their own technology for their own waste, because they know about their waste. So they develop the technology and the plants are running well. Now, our waste is different. It is entirely different compared to other countries. And now we are thinking just to import the technology from other country. So that way that has happened in Delhi almost 30 years back. A first waste to energy plant in India set up at Timarpur near Delhi. I think people might have known about that plant status. It was invested those period. It was installed and hardly it ran for 5 days. It is a week. So after a week, they came to know that Indian waste is very low in calorific value. It is having different fuel characteristics, fuel properties. So they simply shut down the plant, and slowly it became, it's become like non-performing asset. So it is removed and sold. The entire plant was removed and sold as a kabadiwala. So obviously that's why that is one of the wonderful example why in waste to energy we cannot simply import a technology for our waste, because unlike any other kind of industry, if you go to power industry, if you go to chemical industries, any other industry where the raw material is more or less same. If you go to power industry, coal properties are almost same. If you go to other chemical industry, leather industry, steel industry, we can import the technology from other countries. But here, because as such our waste is highly different, we cannot compare with other kind of wastes. It cannot go into, if you import any technology which is not suitable for Indian case, it is not going to work. So that's why there is a lot of potential in India, because so far in this world, nobody has put time and effort and money in developing a technology for Indian kind of waste. So we have a lot of opportunity for young entrepreneurs in India, entrepreneurs or even academic or scientists in India. It is a lot of opportunity for them to develop a technology which is suitable for Indian conditions. That is very critical because our waste is different. And this picture, self-explanatory. We are the best recyclers in the world. No one can beat Indians. The picture itself shows, we used to recycle a newspaper at the end of the month or end of the year at very good commercial value. In Delhi, if you come to Delhi, people used to take it as for, per kg roughly 20 rupees. And even sometime the big bazaar management used to offer per kg 30 rupees. They used to give tokens for that. And even my home, we used to segregate plastic bottles, other kind of toothpastes. If you segregate toothpaste and give it to Easy Day, you will get 5 rupees per each toothpaste covers. So that's why in India everything has a value. So ultimately we used to recycle everything what is available in India. So we must feel proud that no one can beat Indians for recycle concept. We must feel proud, because we should not have, people used to say that we must always learn from others, other countries especially. But when it comes to waste recycling, we are the best recyclers in the world. We recycle everything, but what we throw it out, whenever there is no commercial or economic value attached to it, that only we used to throw it out, like a MSW, municipal solid waste. So we must proud that we are the best recyclers in the world. And when it comes to municipal solid waste, yes, once again, what are the different steps involved? You might have seen there are large number of municipal corporation trucks are playing here and there. So what is the main function? They used to collect the waste, store the waste properly, segregate the waste, transport the waste from city center to that dump sites, and process the waste and disposal of the waste. So these are the 6 different stages are involved. But you hardly seen the trucks are moving here and there. That is called transportation. And collection also, you might have seen people now started collecting the waste from household. So except collection and transportation, hardly nothing is being done in India under waste management. But our rule says you should follow all these things, but we are not doing it so far. That's why we finally end up in creating emission. Why? Because this kind of our population is so high and systematic, and there are different kind of institutions are involved. There are 7. The slide it is mentioned 7, but there are numerous number of institutions. Whenever if you give any work, if number of people are involved, nothing is going to happen. So you should ultimately find out one person to do the work. In India, that is not the case. That's why people used to fight each other. There are 7 different institutions in India. They always putting blame on others, and ultimately nothing is happening in waste to energy sector, waste management in India. And just imagine, we are paying all kind of tax, house tax, water tax. Sometimes in cities, municipal corporations started collecting waste tax as well. I think Delhi they started it. Chennai very soon they're going to start it. Just imagine, for each and every ton they dispose, they spend around 1,500 rupees. 500 is very old figure. You can say nowadays it's become 2,000 rupees per ton they are spending it. So in a city, Chennai, suppose your generation is 5,000 tons per day, you multiply by 1,500, that's much amount they are spending. On what? They are spending 70% for collection alone and 30% for transportation. Only they are doing only 2 functions. And hardly no money, no fund is being spent on disposal, proper disposal, scientific disposal. If you do only 2 activities, that is collection and transportation, and do it and dump it all the waste in the dump yard, it going to create pollution, lot of pollution. That is emission, air emission and water emission. So whatever the leachate generated, it is going to affect our groundwater. So that's why it is very critical. One, the public has to get awareness. Municipal corporations not doing this function, like scientific disposal and treatment. They're doing only collection and transportation. So that's because they're not having enough money for that. All municipal corporations are running out of money. They're not financially sound, so they're going to be able to spend money. So they're also not fault. If you provide enough money or fund, they can able to build the power plant and dispose properly and avoid the emission. And there are there is kind of a systems are there how to transport waste and how to recycle it efficiently. There are different technologies we will see one by one in the coming slides. Is this slide shows there are different opportunities are available how to dispose waste scientifically, and ultimately the waste becomes electricity or fuel or kind of application, thermal applications. And if you can shout out, there are very few technologies which are highly matured, which can be readily implementable in waste to energy. That is pyrolysis or gasification technology, combustion or incineration, and biomethanization. And the first one, landfill recovery, is not possible nowadays because in landfill we are not able to recover the methane, because like if in the case of Perungudi, there's a very big mountain is there. You dig number of pipes. If you dig the pipe, then methane has to come out. So now, but this is not coming out because of our waste crisis is very different. So the use of first technology is not possible. The second one, pyrolysis, combustion. The most prominent is incineration. That is called combustion. So whatever available, you just burn it. Whatever energy generated, you generate the power. So that was the concept. And pyrolysis is not matured technology. And biomethanization is known to everyone. That cow dung based biomethanization. So like this, you have to use it. So there are some kind of emerging technology like plasma pyrolysis, microwave destruction, and laser. These are in emerging technologies. It is either in the lab scale technology or demo scale technology only, not in the commercial level. Each and every technology has its own merits and demerits. The very popular one, that is the incineration plants, MSW incineration plants. It is almost everywhere in the country, everywhere in the world, mostly in Japan and even China nowadays and UK. They used to combust the waste and generate power. It creates a lot of problem, dioxide and furan problem. If you do landfilling, again there is a problem. Methane generation will be there. And if you go for gasification is a technology, is a wonderful technology, but if you are having fuel with high moisture, you need to put more amount of energy for removal of that moisture. And composting is not suitable for mixed kind of MSW, and it creates order kind of problem. So it is not so suitable as of now. That's why waste to energy is very important, and it is we highly recommend waste to energy, because the main thing is that it reduces the volume of the waste by almost 90%. Because the waste, the main issue that it occupies large amount of space in the cities wherever it is located. Very huge mountains are there. It occupies large space because the density is very less. When the density is very less, it occupies more space. So if you install a waste to energy plant, thermal destruction, waste to energy means thermal destruction. So the volume of the waste will be reduced by 90%. So ultimately only 10% will be left out as a ash that we can able to manage very easily. And there are different kind of technologies are nowadays available which can able to control the emission, and safely we can run the waste to energy plant without any emission at all. That's why waste to energy is best compared to all other kind of technologies. Now let us see about what is the potential in India. So whatever we are discussing about waste to energy problem, waste disposal. Yes, waste disposal is one of the main issue in India because it creates emission and it creates kind of carcinogenic gases. But what is the potential? Whenever I say waste to energy potential is lot, you see in 2017 there is a potential of roughly around 5,000 megawatt we can generate from waste. In 2017 means almost 4 years back, the MSW generation was 2,65,000 tons per day in the entire India, not only for vertical cities. Throughout India, if you calculate, this much figure comes around 2,65,000 tons per day. It is a tons per day. So if you use this kind of waste as a power generation, as a fuel, we can able to generate around 5,000 megawatt. This is a potential. It is not actual generation. It is a potential in India. This is the waste quantity is available. This, if we employ waste to energy technology, we can generate 5,000 megawatt. But what happens actually? That we will see. This kind, I think, I hope people aware of biomethane system, cow dung, and all these things. So we can skip. In India, basically, emission standards are really stringent. We must feel proud. We must feel proud that in India we have emission standards are on par with European standards. We are taken the standards from Europe, so we are having good standards. So which ensure that whenever if you operate a waste energy plant, we must follow this kind of norms so that emission levels are very minimal. You see that total dioxin and furans are given 0.1 nanogram. It is very small amount of pollution is only allowed. So that's why our technology should be capable enough to meet this kind of norms. And this is very important slide I used to give you to the audience, because we are from South India, we are very familiar about an equipment called mixie in our household. Because whenever if you come to North India, people used to say South Indians are used to take idli dosa every day. Obviously, we are fond of idli dosa every day. But ultimately, whenever you want idli dosa, the equipment, the magic equipment in kitchen, ultimately that is a mixie. So without mixie, you cannot have a South Indian kitchen. Wherever you go, even I stayed in Japan for 3 years. So we made a custom made mixie in India, and we took the mixie. Although the voltage levels are different, we modified the voltage level and we made a specialized mixie and carried to Japan for our day-to-day work, chutney preparation. So that you might have observed, kind of mixie. Whatever may be the brand, there are different kind of brands available in the market. Whatever may be the brand, you might have observed, the one peculiar thing. It always comes with different kind of jars, small jar, big chutney jar, a juicer, some other kind of intermediate size. There are 3-4 kind of jars. And you might have noticed another kind of, uh, dimension. That is a different kind of blades. It always comes with 3, 4, 5 different kind of blade sets. Why that kind of different blades? One blade is for grinding your coconut. Maybe another kind of blade is for grinding, or crushing, juice for use, definitely used for kind of fruit applications. So each and every raw material, what it shows clearly that each and every raw material, if you change your raw material, you need to change your blade. That is our learning. But just technology, just imagine the technology. We have the technology in India. We can able to reach our moon, what not. Rocket technologies are available. All kind of artificial intelligence. We are better at software and all those things. Why can't we just imagine? Why can't we make a mixie with one jar or one blade? Okay, jar may be different. One blade. It's a versatile blade. Whatever you put, it generate whatever you want. Otherwise it will grind whatever you put it inside. Why people are not doing like this? That's not possible. You cannot have a universal blade in the mixie. If you just put a blade and use all kind of raw material, it's not possible, because we need different kind of output. Sometimes you need to grind, what do you call, turmeric. Sometimes you used to grind coconut. Sometimes you used to grind your rice for rice flours. So each and every application is different. So that's why your blades are different. Similarly, in a power plant, as I mentioned earlier, in NTPC we used to use coal as a material, a raw material, a fuel you can say. There are different kind of coals are available. So if you go for anthracite or if you go for subbituminous coal, the technology is different. That's the right topmost one, pulverized fuel fired boilers. And if your coal is different, suppose lignite or biomass or some kind of thing, you need to use CFBC boilers. So that's why it clearly indicates that if your raw material is different, then your technology is also different. It should be different. Otherwise, the technology is not going to work. The efficiency level is going to be get affected a large extent. Then ultimately, you should leave your system. So that's why the technology is very critical, and it should depend upon your raw material. That's why. Suppose in your household, if you are giving a waste, municipal solid waste, it's a mixture of everything. How can I select a single technology for that? Can I able to select the technology? Suppose if you could segregate the waste, suppose wet waste and dry waste, then it is okay. I can recommend a technology for wet waste. What is wet waste? It is having high moisture, like vegetable peels, food waste. If you segregate the waste like wet waste and dry waste, now I can able to recommend the technology for wet waste as a biomethanization and dry waste as a waste to energy concept. But if you mix everything like wet waste, dry waste, battery, glass, even syringes, needles, diapers, everything, then no one in the world can give you a technology which can able to solve your problem. That is happening in India. So far, what is happening in India? Because as a citizen, we are not putting our effort to segregate the waste. We are putting everything in a single bundle, that garbage, and we are throwing it outside. So no one in the world is ready to, design a technology. It is not possible also. Technically, it's not possible. So ultimately, what is happening? All the waste is ending up at dump yards and creating problem, creating emission, and people are not aware of that kind of emission. So that's why segregation is very important. Segregation at the source is very important. At the source means at the household. So at the household, one has to segregate. You see, there are different kind of segregation, like 5 level of segregation is shown here. But if you go to some developed countries, there are even 7 level of segregations are in Japan. In Japan, I seen, because I stayed there for a long time, I need to segregate each and every day is being allotted for each waste. Monday is for paper, for example. Tuesday is for food waste. Wednesday is for glass. Because in foreign countries, that alcohol is famous. So there are a number of bottle will be there. So Wednesday is for bottle. And Thursday is for aluminum cans. Friday and Saturday is for different kind of waste. So each and every day is being ordered for different kind of waste. And if you are not following, you will be penalized. And there will be always camera will be there. They easily find out who made this, who is the culprit, who mixed the waste. So that's why that level of conformity is there in other countries. But India, to start with, we should start with at least two level of segregation. One is wet and another one is dry. At least two level of segregation. If we can able to do wet waste, that is kitchen waste, I can recommend easily go for biomethanization. Go for biomethanization, produce methane, and methane can be used as a cooking gas or heating application or generate power. And if you go for dry waste, you can go for incineration, generate steam and generate power. So there are different technologies are available for different kind of waste. But if you mix everything, no one can help you and even God cannot help you. So that's why we must start with at least one level, two level of segregation of wet and dry waste. It is very, very important. And what is the status of some plants in Delhi? There are some plants which is operating under waste to energy, that is incineration. That is called mass burn incineration. What I told you, because in India we used to mix everything. So that is called mass burn. Whatever you give waste, as it is the waste, entire waste without any segregation, it put inside the boiler. The boiler will generate steam. The steam will be used to generate power by running turbine and generator coupled to generator. But if you do that, the efficiencies are very low. Your boiler will be subjected to high level of maintenance, and it is having investment cost is very high, and they are not able to successfully run those plants. There are plants in Okla near Delhi. It is 16 megawatt. In Ghazipur, there is 12 megawatt. In again, and another one is Delhi. It is roughly around 12 megawatt, 24 megawatt. So those three plants are running, but they struggle to run because of segregation is not in place, and the maintenance is very, very high. The cost of production is very high, so they struggle to run the system. And throughout the India, you see this picture shows there are 5 different plants in India. Number 1, 2, 3, 4. All 4s are running on incineration based. There is mass incineration. So whatever you give, just you put everything in the boiler and fire it. 1, 2, 3, 4. So all are running with capacity of 12, 24, 16, 12, 14 megawatt system. And number 5, that is the biomethanization system. So what they do, they segregate the waste. Only wet waste is subjected to biomethanization. So you segregate the waste as a wet waste, kitchen waste only, vegetable peelings and food waste. Then they can easily use as a, to generate biomethane. So if you generate methane, the methane gas used to generate power through IC engines. That is 3 megawatt. That is the only plant in India which is running. So this is the status in India so far till date. 66 megawatt is running. And what was our potential earlier as shown? Our potential is 5,000 megawatt. It was in 2017. It should have been 6,000 megawatt by this now, but we could able to reach only 64. Why 64? Because our raw materials are challenging. So that's why challenging means there are certain opportunities, and there are major constraints because it is very new concept, and most of the technologies are imported. No one has given time and effort to develop a technology for Indian waste. So whatever 3, 4, 5 plants I shown last slide, all technologies are imported. So that's why it is not suitable, because imported technology is not suitable for Indian waste. They are struggling to do that. If you can able to segregate, it will run very, very well. And lack of financial resources, because municipal corporation in India are very poor, institutions. Their revenue is only for only from taxes. So nowadays the policy is now coming up, very lucrative policies are coming up from the government. So which is kind of policy guidelines are required, but present guidelines are better. Conducive policies are there which can able to help to promote waste to energy in India. And out of 3-4 technologies, what I told you, one is biomethanization. If you use the biomethanization like only wet waste, we cannot use any other waste. So you have to segregate waste to waste. If you can able to segregate wet waste, you can generate 1 megawatt out of 100 tons per day waste. Okay, 100 tons per day of waste, you can generate 1 megawatt. But if you can go for gasification technology, you could have you can generate 2 megawatt, and mass burn 1.2. So and the fourth one is not technically feasible nowadays. So out of three, gasification is the highly efficient plant, highly efficient technology which can generate more power from the given waste. And there are different technologies. Different technologies are presently in different status. Basically only mass burn is mature technology so far, mass burn technology, and all other technologies are either in development mode or research mode or kind of prototype mode only. And what is the international scenario? How people use this technology? You see, in Japan, because this is a small country, they cannot afford to build Perungudi kind of hill, Perungudi or Noida kind of hill, because they lack space, land. So whatever they generate waste, they go for waste to energy. They burn it, generate power. Ultimately, they end up in small amount of ash. And the ash can be used as a construction material. But you see China, because the country is very big, they can afford to go for landfilling. But for the last 1 decade, they gone for all plants, all modern sophisticated waste to energy plants nowadays is being installed by China. So for the last 1 decade, they installed more than 200-300 plants in China. So they also gone for waste to energy. So these are the growth potential in waste to energy. I hope this animation is visible.
Yes, you can.
Yes. You see, I think we are familiar about, I think a little bit we are familiar about a power plant, a coal-based thermal power plant. And there are only three differences are there between coal-based thermal power plant and waste to energy plant. You see in the leftmost side, you see the truck, municipal corporation trucks comes and discharge the waste to the waste bunker. So waste bunker is one of the very peculiar in the waste to energy plant, because what we discussed earlier, waste is highly heterogeneous. So you cannot feed a heterogeneous fuel into the boiler. So what they do, they prepare a very big bunker, waste bunker. Okay. Suppose the plant capacity is 1,000 tons per day. They generate 10 times. So 10 into 1,000, 10,000 tons capacity. They build very big structure will be there. They put all 10 days waste there. So completely the job is there. You see there are crane, waste crane is moving, So there are two different cranes are available generally. One crane is always be there to blend the waste. So there is it dedicated for blending the waste. It 24/7, it always blend the waste. So what will happen if you continuously blending the waste? You will roughly you will get some stable kind of fuel property. That was the job of the first crane. The second crane used to feed the waste into the grate. It is basically a grate fired boiler. So the grates is designed, whenever that waste is fed into the grates are moving reciprocating grate. Though the grates are so designed that by end of the grate, when it reaches the end of the grate, it ensures the complete combustion. But obviously in India we are using mixed waste. So you can see 30-40% of waste is comes out as a waste. That is a fate of Indian waste to energy plants. 20-30% is comes as a waste, and another 70% is totally burnt, and the flue gas generated. The flue gas goes to the boiler, and I think we are familiar in the boiler function of boiler. It generate high pressure, high temperature steam. It goes to turbine, and it goes to condenser, and cycle repeats. Okay. And the first difference, I told you there are three differences in waste to energy plant. One is the waste bunker, very big structure to mix the waste thoroughly. And the second one is the air cooled condenser, because this waste to energy plant should be located in the city itself. Why? we cannot afford the plant to be located far away from the city. Far away means remote, like thermal power plant. Thermal power plants are located far away from the cities. But here, waste cannot be transported over the long distance because of lighter material, and that's why these plants are located in the city. Whenever you install the plant in the city, there is already lack of water, so that's why people gone for air cooled condenser instead of water cooled condenser. This is the second difference. The third one is whatever the flue gas comes out, it generally goes out at the stack in a power plant. But here there is a gas conditioning system is there. Flue gas conditioning system, cleaning system, you can say cleaning system. By injecting carbon, activated carbon and lime, you can remove all kind of acidic gases, dioxin, furan, SO2, SO3, sulfur trioxide, sulfur dioxide, all kind of acidic gases can be removed by means of injecting lime and carbon. And you can imagine the cost of the activated carbon. 1 ton of activated carbon is 30,000 rupees. So it has to be continuously injected, and lime is little bit cheaper. So this much chemical has to be continuously injected so that whatever the gas comes out, it is pure in nature. And in China, recently people used to say this is a air purifier for the city, because last time when we visited to China, we visited the power waste to energy plant as well, and people used to call it as a air purifier. In Beijing, we have seen a waste to energy plant, and people call it as a air purifier for Beijing. We asked why it is called air purifier, because it takes a dusty air from the atmosphere and it is used in the boiler, and by using injecting chemicals, they are removing all kind of dust, acidic gases. Ultimately, pure air goes out. So that's why they call it as a air purifier. So waste energy is nowadays both, it is disposing both solid waste and air emission as well. So that's why it is a air purifier for the city. In those developed countries, because developed countries, they have enough money to install all equipments, they have enough investment cost, and they afford to invest money on injecting chemicals continuously. It is very, very critical. Whenever a plant runs, we must inject the chemical continuously so that all the chemicals are removed, all the emissions are removed. And this is nothing but a very old concept. It's nothing new. These kind of plants are nothing new, but flue gas cleaning systems are new, which is especially for waste energy plant, because in waste energy plant we are creating a lot of emission by burning waste. Because whenever you burn the waste, because of low temperature, the waste is getting converted into a lot of emissions, like SOx, NOx is nitrogen dioxide, dioxin and furan. So that's why there are some norms. We need to maintain minimum 850 degrees centigrade in the boiler, so that the emission levels are low, dioxin and furans are not formed. But ultimately, whatever may be the reason, just a minute. Hello. हाँ हाँ just 10 मिनट फोन कर दो. So ultimately, our aim is always to reduce the waste reduction. This is the ideal scenario. You can say, ideal scenario. What should be the ideal scenario for the waste management? First, we should always ensure that, on any cost, we should avoid the waste. That is called reduction. And if it is possible, we can reuse it or recycle it. And even if there is a waste, we should segregate the waste. Then you should go for composting. That is the first level of, waste to energy or waste disposal. All wet waste has to go for composting. If any dry waste left out, then only you should go for waste to energy. And ultimately, we should ensure that nothing goes to the landfill. Otherwise, you see the photographs says, you see the livelihood of their, rag pickers. These are the rag pickers. Just imagine their livelihood by picking some of the valuables from the, that waste. You see how they are sacrificing their life in those kind of landfills. Landfills are highly hazardous. It creates lot of kind of hazardous chemicals, and environment is completely filled with chemicals, and it is emission. but you know what to do. Their livelihood is just picking up valuables and selling it. So if we can able to follow this ideal scenario, ultimately we nothing is ended up in landfilling. So their level of life is also getting improved. So ultimately the source segregation is very important. Otherwise we end up in all kind of waste. You see, in a study, it gives that in average size of kitchen bag in a four people family. Nowadays, we are having a single family system with only two adults and two kids, more the most four people, which can generate roughly around 3-4 kg of waste, which can light up 100 watts bulb for 2 days. This much amount of energy is there. So don't think it's a waste, but don't throw it out as a mixed waste. We always segregate the waste, at least wet waste and dry waste, so that a disposal will be much easier. You just imagine the situation in Japan, because I am from I can able to quote some example from Tokyo. You just imagine, can you identify the power plant in that picture, left side picture? Except chimney, because chimney is there, tall chimney is there. That's why people used to identify there is a power plant. But if chimney is not there, people cannot find out the differentiate between the power plant and the other structure. So their waste to energy plants are so ideal, it never generate any emission. So technology, equipment, everything is is sophisticatedly designed and operated. They inject all chemicals throughout the day, 24/7. They ensure no pollution comes out from the plant, no chemical, no waste, no noise, no stinky odor, no kind of any kind of disturbance for the locals. That's why they allow to build the plant in the city itself. Waste to energy plant is located near hospital, school, train station. Is it possible in India? No. People, whenever you stay waste energy plant in India, people try to oppose. Why? Because that previous examples, whatever the plants are running, is not up to the mark. It is not generating. It is generating a lot of emission, all kind of problem. But in developed countries, they invest money. Their their design, their operation is so controlled, so transparent, it generates very least amount of emission only. So that's why this is very critical to control the flue gas conditioning as well. And one can say that why can't we invest money in segregation equipment? Why you are asking for people to segregate? Source segregation. I asked for source segregation. Source segregation means segregating at the house only, wherever it generated, household. Yes, there are machines are available. You see, there are a lot of machines are available. We visited a plant in Sweden. In Sweden is the only country in the world which import waste from UK. It not only imports waste, so to dispose the waste, they are also getting money from UK, from London. So Sweden, there is a place called Vestas. So that place, the waste to energy plant is located. They get the waste from UK. They get the waste and also they get money for the disposal. So what they do, they invested a lot of equipments like 1 to 5 different sections are there: feeders, shredders, classifiers, conveyors, screw conveyors, metal detectors, segregators. All equipments are is a very big complex, but the investment cost is very high, really high. One cannot afford. It is the only plant which is operating in Sweden, which is having all kind of mechanized segregation. First one is in large amount of space is required, and next one there are lot of investment cost is involved, and third one there is a lot of power consumption is required. O&M cost, operation and maintenance cost. In a power plant, suppose I shown you some plants. All plants are in the either in the range of 20 megawatt, 12 megawatt, 16 megawatt. But if you employ all kind of mechanical system, it consumes 50% of the power. Then ultimately you will get very less grass output. So that's why then if you employ all these machines, it is become economically unviable. It is not commercially viable plant. So that's why source segregation is very critical. So by learning all these, experiences in NTPC, we have gone to different, countries and to study the technologies, and finally we understood, the customization of technology is very critical, and we must develop a technology in India itself, because in India our waste is different. No one can going to help us. We must develop our own technology because our waste is completely different than other countries' waste. Even if you import the technology, that has to be optimized to Indian condition. Optimize means we must change designs, and we must carry out some modifications, major modifications, so that it is suitable for Indian conditions. Without which, all the import technology is not going to work. So with this mind, we have gone into different initiatives, like, one of the initiatives, like, why not we convert waste into fuel? Because I already mentioned, waste to energy plants are capital intensive. Per megawatt, it requires around 20 crore to 30 crore. But in a coal-based power plant, per megawatt, if you want to install per megawatt, the cost is 5 crore or 6 crore. But waste to energy plant, per megawatt is 20 crore, 30 crore. It is highly capital intensive business. So, well, how to avoid those kind of investment? So we have gone for a different kind of approach. Why not we convert this waste into fuel, some kind of fuel? Okay, when we convert waste into fuel, then you blend with the coal, because already NTPC having a lot of boiler, turbine, that already equipments are already available. So just blend the waste with the coal and use the already existing available equipment. Then it will be economically easier, simple. So we thought of that way, and we have gone for some technology development that is called hydrothermal treatment. We are successful, and we are having a different, pilot setup and one tons per day setup at different NTPC projects. And we also gone for running, as a CSR, we have corporate social responsibility. We are also gone for running that compost plant at Varanasi. And the third one is the first of its kind in India, that is 24 tons per day gasification plant, waste to energy plant in Varanasi. It is generating 200 kilowatt. The technology is developed in India. That I will give some kind of introduction to the plan. And we regularly organize conferences, and lectures, various platforms to create awareness among people. People has to aware what is going to happen when we don't segregate, what kind of technology is suitable, those kind of things. And we also gain momentum by publishing UI, expression of interest, setting up waste to energy plant in India. And right now we are in the process of setting up two plants, that is 1,000 tons per day plant at Surat, that is Kawas city, and another 2,000 tons per day plant in East Delhi Municipal Corporation in Delhi. So as you know, 100 ton per day will generate 1 megawatt. So 1,000 ton per day, anywhere between 10 to 15 megawatt, and 2,000 tons per day plant will generate roughly anywhere around 20 to 30 megawatt. And this is the first our approach towards converting waste into fuel. So by using hydrothermal treatment, means high pressure, high temperature steam is used to cook the fuel. This technology is simple. You know how the coal is generated in the well, if you put high temperature, if you make your organic material, like whatever the trees and organic material, if you subject that high temperature, then it converts into coal. That was the normal coal, how coal gets generally changed from one organic material to coal. So similarly, we use the same technology, the qualification process. The same qualification process is being, we just copied that same technology. What we did, we have a reactor into which, just imagine that, the photograph at the bottom, it shows, the fuel which is obtained by processing the waste. It is exactly looks like a coal. So this can be easily blended with the coal, and with the already available equipment, I can easily run the plant without any expenditure. Otherwise, if you go for waste energy plant, you need a lot of money for investment. Investment cost is higher. But if you can convert this waste into coal kind of product, we can easily blend with coal. You see, this is a small setup. We made it in our NTPC R&D facility. We used a high pressure steam. So there is a blue color equipment. This is a boiler which generated high pressure, high temperature steam. We took waste from Greater Noida Authority. So if you put the waste in the reactor and subject into high pressure, high temperature steam for roughly around 1 hour, you can end up with coal kind of product. This is coal having high GCV, grass calorific value. You see, just imagine 4,000 kilocalorie. It is as good as Indian kind of coal. So we can replace some kind of coal in the power plant, which can easily generate power. This was the one of the initiative to in BPC. And another one, we also started, as a CSR, we made a plant which was not functional. We took the plant, we revived the plant with lot of, repair and maintenance we did. And now the plant is running and we are generating compost out of waste. And even with the compost, we need to segregate. You see, that's a major hurdle in the plant. There's equipments are installed to segregate. As you know that by just employing machines, we cannot segregate 100%. With a lot of difficulties, we could be able to run the plant and generate organic manure. And this is the first of its kind in India to use a domestic technology, make in India concept, because we know that we understood that, only technology which is, the equipment, the only equipment which is exported from India is a gasifier. Even, UK, there are a lot of establishment in UK. They used to get gasifiers from India. So by understanding this kind of facts, we are given opportunity for Indian company to generate manufacture a gasifier, which is suitable for generally gasifiers are suitable for biomass, uniform fuel biomass. But as we know, waste is highly heterogeneous. We customize the technology for this waste. Just a minute. Hello. How this been like? So we are successful and the plant is running and it was commissioned in the year 2018. It generates around 200 kilowatt of power out of 24 tons of waste, 24 tons per day. It is a demo scale plant only. It was located near Varanasi, the city of Varanasi, and it is located near the landfill, the mountain, near the waste mountain only. And basically, the salient features are the capacity is 24 tons per day. It generates 200 kilowatt of power, and the land requirement is very compact. Because the entire facility is very compact, it needs only 0.5 to 0.6 acres of land. So this was inaugurated in 2018. The main component of this technology is, gasifier. You know that gasifier, whenever you heat fuel, it generates gas, gaseous hydrocarbons. So here what we did, we put the waste material into the gasifier. This is this is basically a controlled gasification process. The oxygen content in the gasifier is controlled by means of a oxygen separately. We supply separately oxygen from the oxygen plant. There is a plant which is dedicated for generating oxygen gas. So by controlling the oxygen, we can control the gasifier output. So that gasifier output is carbon monoxide, CO. Whenever the CO comes out, it comes out at high temperature and lot of impurities are associated, because as we know that, whenever you heat, there is a tar is a main issue. The tar also used to come along with the gas. So there are some systems which can cool the gas and remove the tar. There is cooling and cleaning systems are there. Once you clean and cool and clean, the pure cooled CO, carbon monoxide, is given to IC engine, modified IC engine. It's only the inlet valve is to be modified. Otherwise, all the things are exactly similar to a diesel engine, and the engine is IC engine only. So it is coupled to generator, generate power. So this is our complete setup. So it is that this design, everything, manufacture, everything done in India. So these are some of the pictures, and this is completely, one can operate from remote, start up, shut down, regular running, everything can be controlled from remote. All data acquisition systems, DAS, everything is there. There are some other pictures which shows, and the gas quality. You see, just imagine this is a gas quality like your LPG stove. In LPG stove, the blue color flame used to come out. So similar kind of quality of flame used to get it from the gasifier. So once you get this kind of flame, the next that generator, the gas will be supplied to the IC engine to generate power. These are some of the pictures shows the IC engine pictures. And there is a, I think video, video is not running anyway. And ultimately, by end of this presentation, I need to give more focus on waste segregation. Once you segregate the waste, then we have 4 different technologies. But still, all these 4 different technologies are still need to be optimized. That's why for an Indian young entrepreneur or even in the scientist, there is a lot of opportunity to work on these 4 different kind of technologies. Incineration, if your waste is completely dry waste, go for incineration. If you are able to generate wet waste, high graded segregated waste. If you are getting highly segregated waste, go for biomethanization. If you are having intermediate, go for composting or gasification. Simple. So if you are having highly segregated wet waste, go for biomethanization. Little bit, kind of less segregation, go for composting. If you are having high moisture content, go for incineration, and dry waste to go for gasification. So out of this, only these 4 technologies are blending up. These 4 technologies can able to solve the Indian waste to energy problem. So this is very critical. So there's a lot of potential still available for, there's a lot of challenges and opportunities are involved in Indian waste to energy sector. And like NTPC as a learning organization, nowadays we also promote how to dispose ash from power plant. So we always go for giving opportunity for young minds to generate ideas. If you have any kind of ideas, any kind of like how to use ash in construction, coal ash, construction, road laying, cement manufacturing, agriculture, you can very well give idea, and NTPC can very well able to appreciate your idea and try to implement and reward suitably. And another one more area in waste to energy in a thermal power plant, we used to have lot of cooling water systems. So we used to spend a lot of water for cooling the condensers. So if any idea is available which can reduce the water consumption, which is very well accepted. And recently NTPC came up with the idea of how to solve the problem of the Punjab and Haryana biomass problem. It was there is a challenges was posed. If anyone able to give the kind of solution, there was a 24 lakhs rewards. Even NTPC was ready to fund for their technology development. So there is always opportunity in India, especially in NTPC, to go for new kind of technology innovations. Although the date was 10th January, you expect more kind of kind of announcement in coming days. So with this, I thank you for this wonderful opportunity, and I can may I ask Mr. Srinivasan to run the video. We made a small video on the Varanasi 24 TPD gasification based waste to energy plant. I think
Sumati madam, can I share the screen here? Is that possible? Can I share my screen? Is that possible? So that you can show the video.
State Center, madam.
Panla sir.
Okay, sir. Thank you. Thank you, madam.
Are you playing the video?
The senior center screen வரல.
Sir?
உங்க screen வரல, டிஸ்ப்ளேல வரல. வீடியோ ஆன்
என்ன வரல சார்? ஸ்கிரீன் வரலையா?
வீடியோ ஸ்டாப்.
1 minute sir, 1 minute. இப்போ வருதா சார்?
வருது.
இப்ப சேராது போங்க.
ஓகே ஓகே. ஃபர்ஸ்ட் லிங்க் பண்ணுங்க.
Now okay sir?
சவுண்ட் வரல.
வருது சார். வேற ஏதோ சவுண்ட் இருக்கு. இல்ல சார். இது
சார் ஸ்கிரீன் ஆகுதா?
ஸ்கிரீன்ல தெரியுது சார். வாய்ஸ் ஆனா கிளாரிட்டி இல்ல. வாய்ஸ் வரல.
வாய்ஸ் ப்ராப்ளமா?
The audio is not clear, sir. We'll see in YouTube.
வாய்ஸ் கிளியர் இல்லையா மேடம்? நான் லிங்க் ஷேர் பண்ணி விட்டுறேன்.
Okay, sir. No problem. We will see it in YouTube.
I shared the link. I shared in the link
No
group.
problem, sir. We'll through it.
I think one can able to see freely in the
Yes,
YouTube. I think
yes.
it is the link is available in the YouTube.
Sure.
Okay, sir.
So that's why basically basically there is a lot of potential in India for waste to energy, especially this area lacks lot of scientific innovations and development in India, because waste is highly heterogeneous and it is an Indian kind of waste. We cannot simply copy the technology from outside. So there comes a lot of opportunity for Indian scientists, kind of academic institutes which can put more effort on developing some kind of technology which is suitable for Indian kind of waste.
Okay,
So that was my ultimately my aim of giving this kind of presentation. So
sir,
you are
I
free
have a
to-
question, sir.
Yes, yes.
Sir,
Yes.
now I have a question. How can we segregate the e-waste, sir, electronic waste?
In electronic waste, there are different technologies are available. One is wet, and another one is dry method.
Okay.
In wet technology, there is a density based technology is there. Based on the density difference, we can segregate along with the thermal. So there is a little bit complicated. You have to use kind of water as a medium to segregate different density materials first. So once you segregate the based on density, then we use the thermal treatment for taking out each and every component of the waste, because there is a different kind of metals are available in the e-waste, like even gold and lead, copper, that can be segregated easily, but it requires a lot of energy and input.
Sir, I have one more question, sir. Hello.
Yes, ma'am.
How can we get the e-waste from households, sir? In foreign countries, which method they are adopting?
In foreign countries, the method is that first method is that each and household they have to give it to the recyclers. Suppose you are buying a TV, the TV supplier has to take it back mandatorily. That supplier, whoever may be the supplier, suppose maybe Sony as the TV supplier, then you should give that that Sony supplier should take it back from the customer, end customer.
Okay,
That
sir.
is their responsibility. It is the responsibility of disposal of e-waste, not
Okay.
with the customer. It is with the manufacturer.
Okay, sir. The
That's
main
why it is
disposing
easy.
e-waste are the bulk.
Yes, ma'am.
Okay, sir. But in India, the main disposable items are mostly the bulbs. Now, sir, how can we get those things from household, sir? Actually, we are
That's
put it
why.
in the
That's why.
dust itself.
Yes, that is wrong, madam. You cannot put that dustbin, because those bulbs are having different kind of gases, acidic gases. Once it break, the acidic gases comes out. It will affect that the people maybe standing nearby or living nearby. So it's
Okay.
better to leave it as such, and it has to be taken to the recycler, and properly it has to be handled. It is not so easy. Handling MSW by household is easy, but other e-waste and hospital waste has to be disposed only by the authorized waste disposal agencies. We cannot have the authorization for handling those kind of wastes, basically.
Okay, sir. And coming to the human waste, still the people are used for removing those sewages and all, sir. What is the steps the government has taken to dispose those materials, sir?
Yes, in those area, na, particularly in those area, I think you can appreciate there are a lot of recently there are a lot of channels are coming up. Young entrepreneurs are coming up with some kind of automation, how to take out that human waste from the tanks and how it can be squeezed out. The water can be squeezed out. That can be used as a fuel. Even now, people are using as a fuel to generate power from the solid waste, and liquid waste can be treated by water treatment system. The technologies are
Okay,
available.
sir. Thank you. Okay, sir.
For human waste, technologies are available. The solid waste can be squeezed out from the human waste, can be used as a fuel for power generation. Power generation means any thermal energy generation can be possible. The liquid waste can be easily treatable by means of any kind of water treatment system. Sewage treatment plants are available.
Okay, sir.
To support the Dr. Muthuraman's presentation, I think many of you might have visited Singapore, and you can see gardens by the bay. In 2016 onward, they started entirely recycling their output generated by the viewers. Whoever is visiting the campus, all the waste are dumped and it is gasified. And the gasification, one half is going for thermal cycling. They use for HVAC system. And the byproduct is come as biochar, which is used for a horticulture purpose, because entirely it is surrounded, it is entirely enclosed structure. It's full of HVAC system. And it has 1,000 varieties of species of plants in it, and the biochar is being used for building their horticulture. So this is the technology which is available in Singapore. This is zero waste output concept. They don't generate the waste outside the premises. Everything is being consumed by the gardens by the bay.
So same concept is used in NTPC.
I'm not sure.
The same concept is used in NTPC township. We all our township in NTPC are zero waste compliant townships. We all the waste is disposed in the township itself. Either we use it for compost or kind of power generation or thermal generation. So nothing goes out of our townships, NTPC townships.
Okay. I think we can enter the session, sir. Is it? Hello.
Okay, sir. You can tell. Thank you very much, sir.
Okay.
You have discussed a lot, sir, with your short span of time. I thank you very much, sir. Honorary Secretary will give the vote of thanks.
Respected engineers, today, first of all, I thank our Tamil Nadu local state center chairman and secretary for giving us opportunity to conduct this online webinar class. And secondly, there's a 1.5 hour session, sir. It was a very nice. I didn't change my eye from outside, so I was clearly watching. And how can we I utilize this project in Tanjavur area? So that is the main thing. In what way, whether I can utilize the IEI or any Rotary or any other community basis. Think how can I utilize in a short how much. ஸோ யாரையாச்சும் இந்த ப்ராஜெக்ட் எங்கேயாவது எடுத்து இங்கே பண்ணணும், அதுக்கு என்ன பண்ணலாம் அப்படிங்கிறது தான் என்னுடைய திங்கிங்காகவே இருந்துச்சு இந்த லாஸ்ட் 1.5 hour ஃபுல்லாகவே. இட் வாஸ் அ வெரி நைஸ் செஷன் சார். Definitely will approach you, sir, and how we can get this particular project to in our town, sir. Thank you, sir. And Srinivasan, sir, thank you very much for your introducing Dr. Muthuraman, sir, and giving a wonderful session to Tanjavur local center. And thank you, Madam President, Chairman, Madam. Thank you, and thank you all who are all participating. Thank you very much.
Thank you. Thank you.
Thank you, Dr. Muthuraman.
Thank you.
We can end the session.